Good morning, everybody, and welcome to today's webinar on circuit breakers, whereby we will be showcasing circuit breaker technology and the difference between discrimination and cascading. The webinar is approximately 90 minutes long, and our presenter today is the fabulous Christo van Rensburg, who is our power distribution, protection, and enclosures expert, aka our product manager. So what I'd like to do is I'd just like to run you through the just a few overall guidelines today. I will be co-hosting with Christo. My name is Karen Zotter. I'm the marketing manager at EM. Please, if we can ask you to have your 2020 EM catalog on hand, or if it's easier, download the digital catalog at www.em.co.za. Also, you'll notice that your video and microphone have been switched off. This is to reduce the chances of failures or freezing during the webinar. If you do have any questions, queries, or concerns during the webinar, if you sort of toggle your mouse towards the bottom, you'll see there's some control panels, and it showcases a chat, raise hand, Q&A functionality. And so if you wish to, for general discussion, please make use of the chat function. If you wish to ask a verbal question, please raise your hand, and please to direct all presentation-related questions to the Q&A function. We'll try our best to answer them during the session. If we can't answer them during text, I'll be stopping Christo so he can give us a full rundown. The live webinar presentation is recorded and will be emailed to the registered email address that you registered on Zoom. And upon completion of the webinar, if we can ask you to please assist us by completing the webinar poll at the end of the session. This just helps us to improve our overall experience and just to provide you with better customer service at the end of the day. So if there's any particular information you're looking for, or if there's any up-and-coming features, any up-and-coming webinars or particular features you'd like us to focus on, then please do make a comment in the poll. So I'm then going to hand over to our product manager, Christo, and it's all yours.
Thank you, Karen. Hopefully I'll also get the recording. The fabulous Christo, I will need to show that to my wife. I think she will enjoy that. Good morning, everybody, and thank you very much for your time and effort in joining this webinar. Hopefully you'll get some information out of it that can be useful going forward in projects that you'll be doing. So just a quick rundown of the agenda. I will quickly just quickly run through the company profiles of Electromechanica as well as Hager. We're discussing some miniature circuit breakers. Then there's a lot of markings on miniature circuit breakers. So let's quickly run through those markings and what they mean and why they're there for. Quickly explain the tripping curves that's available. Then as well as technology used in miniature circuit breakers. So we talk about thermal and talk about magnetic. What is it? What's the purpose of them? Quickly run through the offer and the miniature circuit breaker range that's there. Can miniature circuit breakers be used in DC applications? There's a table that I'll quickly explain to you. We'll do a short history on the RCDs, where the first RCD was manufactured by who. A quick quiz there, so stay tuned. Then RCDs, there's ELCBs, there's RCCBs, and what does they all mean? We'll quickly go into a break. I'll try and explain to you guys the difference between cascading and discrimination and why they're so important to know. And then if time permits, I'll run through the miniature circuit range in detail, but we'll see what the time allows us to do. So let's start off about the company profile of Electromechanica. The first time I saw this, reading it about 2 weeks back, I actually felt very proud of working for Electromechanica and see where the company came from and how it keeps on growing. So we are about 250 people working for Electromechanica. Might be 249 after today, depending on the feedback we get from the webinar. So please rate us afterwards. We've got 11 distribution hubs. We're active in 12 countries. warehouse space of just over 24,000 square meters, which is a lot of warehouse space. We've got 120 plus wholesaler distribution partners. Last year, we delivered just over 6.4 million items delivered. And then the one thing that makes us stand out above a lot of our competitors is the 97% on-time deliveries. That's fairly impressive. If you speak to some of our customers in a year about other companies that cannot deliver, issues and problems, we are on the top there, beating all the competitors. Dave van der Berg, the founder and chairman of Electromechanica, he said, serving the industry for 3 decades, we remain committed to embrace new technology and pushing the boundaries of industry best practices to ensure we provide products that meet the highest standards of safety and compliance, which is so true in our industry today. Then just some of the background of Electromechanica. Started off in 1984. As you can see, they keep on growing, getting better. Opened a branch in Cape Town in 1994. Growing stronger, keep on growing. Opened up the Boksburg branch in 2015. In 2018, they've opened the branch in Nelspruit. And then in 2019, the Bloemfontein branch was opened, as well as the Polytech joint venture mechatronics training division. We've got here at the Electromechanica premises in Wynberg. All the information about the training is available on our website. If you should need more information about it, you can just go to the website and find more information there. Then, as Electromechanica, Hager is purely owned family company. They've been around also a very long time. They reinvest around 6% of their turnover into R&D, which is a fairly high figure percentage-wise. Normally, you talk about 4, maybe 5%. 6% is good. They employ over 11,400 people. I'm not part of that figure because I don't work for Hager. I work for Electromechanica. They've got 23 production sites all over the world. I've been fortunate to visit some of them in Europe. And the quality of their products are really outstanding and good products. Daniel Hager, the person in the picture there, he's the 3rd generation of Hager family. So still a family-owned company, as I mentioned. Then, just for the fun of it, angry husband sends an SMS to his mother-in-law. Your product daughter, I think this husband is most probably a product manager, not cooking food properly. So the smart mother-in-law replied that the product was sold food stewards. There's no warranty, no returns, and that the manufacturer is not responsible for that. So all that I can say about this is that luckily Hager, as well as Electromechanica, is not run by a mother-in-law. Then a definition from Hager about a miniature circuit breaker. Circuit breaker is a switching device that interrupts the abnormal fault currents. It is a mechanical device that disturbs the flow of high magnitude fault currents and in addition performs a function of a switch. So if you didn't know it, that's what a miniature circuit breaker MCB is. Then getting onto the markings of a product. As I mentioned earlier, there's a lot of markings and information on a product that, what do they mean? What is it? Why is it there for? What can I do with it? So first of all, you'll have the product reference. So there's the current, the tripping curves, the brake capacity, and then the product miniature circuit breakers is normally thermomagnetic products. But to go a little bit deeper into this and what does it mean? So if you look at the product reference number, in this case, it's a NFN 110. So in that reference number, we know that it's a 10 Ka product. We know that it's a C-curve tripping curve on the product. And then on the tripping curves, I'll go into a little bit more detail on the specific tripping curves and what do they mean. The NFN in that reference number, I also know that it's a 1 pole. I also know that it's a 10 amp circuit breaker. All of that just in the reference number. But how can we expect the customers to know that NFN 110 means all of that? So then you will have a C10 on the product, which means it's a C-curve product. 10 amp, again, it's mentioned there. Then you'll see that there's, on the braking capacity, there's 6,000 in like a block there and 10 K next to it. So because Hager sells internationally and work to a few different standards, the 6,000 is also a fault level, which is rated according to the IEC 60898 standard, which were never adopted in South Africa. It is internationally 60898 is seen as a residential product. And then what's important for the South African market is the 10 Ka written on the product. So that's done according to the IEC 60947-2 standard, which is more applicable to South Africa, and internationally that is seen as the industrial standard. For South Africa, we also need to comply to compulsory certification, which is VC 803-6 for circuit breakers, and that refers back to the IEC 60947-2 with a few amendments. But I'll show you later on that even in there that we do comply to all these specific standards and requirements for the South African market. Then on the right side of the product, you'll see there's like a schematic diagram there. So in there, it just indicates to you that this product is it's got thermal protection for overcurrent, it's got a magnetic protection for instantaneous trip, and that it's also can be used as an isolation function. So again, if you look at the SANS 10142 standards for South Africa, which is the installation regulations, it states that in a distribution board, the main incomer must be able to do isolation. So the first breaker in your DB is supposed to be an isolator, but you have to put an isolator and then a circuit breaker actually defeats the object. So with the Hager product, because it does isolation function, you can use a Hager breaker as a main incomer with isolation and overcurrent and short circuit all in one product. Then the pad locking device, obviously we'll know that will be for lockout procedures. The nice thing about the product is that you can lock it out in the on position and in the off position. So now you will ask me, so why do you want to lock a circuit breaker in the on position? That is for critical equipment where you don't want somebody to physically switch off the product by accident or on purpose, you never know. So you can lock it out in the on position, but keep in mind that the product inside will still trip inside, although the top is in the on position. So even if overcurrent or a short circuit appears in your system, the circuit breaker will internally still open safely and protect the installation. Just on that, keep in mind that a circuit breaker is installed in installation not to protect your equipment, but it's there to protect the installation. So normally it's there to protect your cables and stuff like that. So if you want to go deep into it and you would like to protect an electric motor or something, the best to do there is to add a contactor with a overload to get the settings closer to protect the motor, because the circuit breaker will only protect it on short circuit. But for overcurrent, obviously, overload would be a lot better to do that. Then on the side, you'll also see that there's a opening there. You can remove that clip there to install accessories to the side of it. So it's there to fit a UVT, a shunt auxiliary, or a alarm auxiliary. And I'll show you a little bit later on how that is possible to fit these accessories. There's a slide on that. And then obviously the front label there for you to put a label in there, circuit 1, circuit 10, or light circuit, or plug circuit. Just open that flap and insert your label in there. Then some more markings on the side of the product. So if you take a product, you will physically see it that there's markings on the side of the product. These markings are also there for information. So you'll see that on the side it says that IEC has been tested to IEC 60947-2 on the side of the product. On the certificate, on the test report and test certificate that we get from a third independent laboratory, it will state there that it's been tested according to IEC 60947-2, but also the important part is that it mentions there that it's been tested according to SANS 556-1, which is for the local standards. So that is the IEC 60947-2 with a few amendments to fit the local standards for South Africa. This was a snapshot from the NFN test certificate. Then it mentions there ICU equals to ICS. Also, a good thing to know is that your product is rated at 10 Ka. ICU equals to ICS. So ICS is normally you get a fault in your product, it trips, you go and switch it back on that same fault in the line, and it opens again safely. So that rating there is the first rating on your product that's rated at 10 Ka. Then you then close it for a third time or a second time, and it opens for a third time. What it means is that on that second close and the third break, the fault level on that product still stays 10 Ka. If it reads ICU equals to 50% of ICS, what it means on the second close and the third break, this product or that product is not rated at 10 Ka anymore, but only dropped to 5 Ka. So I think what's supposed to be happening is when there was a short circuit on the application, you actually need to make a mental note of it or make a note of it. And then after the second or third short circuit the product has seen, actually the best is to replace that, because each time the fault level will drop on the product. And that's on all products, even on molded case circuit breakers, you'll see a similar rating on it. Then also important for the South African market, because we are a fairly warm country, the circuit breakers has been calibrated to 50 degrees C. So when it's installed in a distribution board, the temperature inside there can go up to 50 amp, and you do not need to derate your product. By derating, we mean if you go to an installation where it is 60, 65, 70 degrees inside your board, this breaker, because of the thermal principle inside it, and I'll get to the thermal side of it, but because of the thermal technology inside it, it will start bending the bimetal strip inside, and a 10 amp circuit breaker may not be 10 amp anymore in a 65 degree application. It may only drop down to an 8 amp, 7 amp circuit breaker. So just information to know that it can do up to 50 degrees C without derating is required. And then obviously made in France. Yeah, it's good quality products. As I mentioned earlier, I've been fortunate enough to visit the factory where they do manufacture these products, and believe me, I've been to a few factories. The standard is very, very, very high. They get audited on a yearly basis. Every 3 years, they need to redo applications for ISO certificates and all different types of certificates from all different types of certification bodies, DECRA, IEC, CE, NF. So, yeah, very high quality products that Hager manufactures. Then to get to the explanation, or try and explain to you what the thermal principle we talk about. So when we talk about miniature circuit breakers, we normally say that it's a thermal magnetic product. So what does the thermal mean, and what does the magnetic means from this? So the thermal part is your overcurrent technology that they use inside the product. So they use they use a bimetal strip, so it's two different metals that they put on top of one another, and then the currents flow through it. And the higher the current flow, obviously the more heat is generated, and this heat then bends the bimetal strip inside the product. And then this will then eventually, when it reaches a certain current or temperature, then it will then trip the product, and your product will open safely. And this is where I mentioned that the D-rating of the product comes in. So these products are calibrated at 50 degrees C. So even if the temperature inside the product is, or inside the distribution board is 50 degrees C, the bimetal will stay in the same position and will not trip. When we get to the tripping curves, you also see that circuit breakers, when it's rated at 100 amps, will be able to carry 100 amp and actually never reaches the tripping curve, and it will carry on forever and a day, and it will never trip. Then we talk about as I said, the thermal, and then there's also a magnetic part or magnetic technology inside the circuit breaker. So what is the magnetic part of the circuit breaker? So magnetics is the what we talk about, the short circuit protection of the circuit breaker. So on short circuit, the magnitude of the fault going through a circuit breaker is huge, and you need to disrupt that current as fast and as effective as possible. And that's where they use the magnetic principle inside the product. So under normal conditions, nothing will happen because the magnetic field is too slow or too small to actually move the plunger inside the breaker. So you've got this coil going around a tube, and then this coil will obviously create a magnetic field. And when there's a massive short circuit going through the product, this will obviously create a force and push down the plunger and hit the trip bar, and again it will open the product very quickly. They say in less than 10 milliseconds, which is fast, because the longer you keep that short circuit on your installation, the more damage it can cause on your installation, on your cables and everything else. So you need to open the short circuit as quickly as possible. So that's the explanation for the thermal part of it and the magnetic part. So going forward, if they talk about thermal magnetic, you understand thermal is overcurrent and magnetic is the short circuit principles.
Christo, we've just had a question come through. Can you please clarify more on LCE equals LCS? When does one replace the circuit breaker?
So that's, yeah, it's a good question. Difficult to answer, because if a circuit breaker has seen the full short circuit, so let's say it's a 10 kA miniature circuit breaker, and it hits a short circuit of 10 kA, it will open that fault of 10,000 amps safely. You can then close it back onto that same 10,000 amp fault, and it will open again safely with no damage to the circuit breaker. If it is ICU versus or equals ICS, it would you can then close it for a second time, and it will open for a third time and handle the 10,000 amps. If the breaker is rated 50% of ICU equals to 50% of ICS, as I said on the second close, third opening, it will only be able to handle 5,000 amps. So if the board is rated 10,000 amps, the fault level 10,000 amp on your board, on the second close and the third opening, that product can explode and cause more damage inside the board. So I think a lot of the time we assume that you can switch a breaker on and off and on and off and nothing will happen. It can be true on overcurrent, but on short circuit, the magnitude going through the product is huge. And yeah, you're supposed to keep record of the amount of short circuits going through a product and rather replace it than trying to take a chance of it. Hager circuit breakers are very safe. They are designed not to rupture to the front, but rather up and down to protect the person standing in front of the product. But can only protect you that far if it goes through a short circuit numerous times. So hopefully that I explained that. But otherwise, Karen, what they can do is they can always send an email. I can contact the person and we can take it from there for more explanations. Okay, then getting to the different tripping curves that's available from Hager. So the three tripping curves here is a B curve, where we talk about 3 to 5 times IN, the C curve, which is 5 to 10 times IN, and then the D curve, which is 10 to 20 times IN. And what does this mean? Why do we have different tripping curves, and what does this 3 to 5 and 5 to 10 times IN mean? So on the next slide, I have actually put all three of these tripping curves onto one another and combine them into one slide. And I'll give you an indication of what the meaning of all these different curves are. So B curve is normally your fast tripping curve to protect sensitive equipment. C is the standard norm that's normally used in residential, commercial applications. And then D curve is seen as a slow tripping curve, which allows a little bit more inrush, especially for motor applications. So you'll see here's all the curves combined, the B, C, and D curves. And what do they mean? You'll see that on the thermal part of the curve, they all are actually the same. It only comes in here with inrush and short circuit applications where there's a difference. So as mentioned, the B curve will allow you 3 to 5 times inrush current. So for example, we'll take a 100 amp miniature circuit breaker on a B curve. You want to protect an electric motor, which the rated current of that motor is 100 amps. So on startup, B curve, on startup, a motor will take 7 to 10 times the inrush current. So if it runs at 100 amp, when you start that motor up, it will go to 700, 800 amps, which will fall into this category here somewhere, and it will go into the short circuit application or the magnetics of the B curve, and the B curve circuit breaker will trip, and you will think that there's a problem on your installation. In the meantime, it's just because the B curve circuit breaker cannot handle that amount of inrush. So, for example, we'll take a 100 amp circuit breaker, a C curve, and just to prove to you that at 100 amps, it will never touch the tripping curve. So your 100 amp is 100% is down there, and it will never touch this tripping curve. So your breaker, rated 100 amps, will run at 100 amps forever and will never trip. It will only start tripping, as you can see, from 113%, it starts touching the tripping curve. So you can have a look at the time there, you talk about 10,000 seconds before this breaker might trip at 113%. So if you then take that same circuit breaker and you put 200 amps through it, what will happen is you can go to the 200 percentage mark. You can draw a line upwards where it touches the curve at the first time. You draw another one up to where it touches your curve the second time. To the left, from both these points where it touch your curve, and you will now see that a C-curve 100 amp circuit breaker running at 200 amps will only trip between 6 seconds to 40 seconds. That's according to the IEC table, and all products are tested according to this. So the Hager circuit breaker, 100 amp, putting 200 amps, will trip between 6 to 10 seconds. Keeping in mind, this is calibrated at 50 degrees C. So if you go in a panel where it's 40 degrees C, this product might trip faster at 200 amps because of the temperature inside your distribution board. And just while we're on there, just if you do have a problem in temperature in your panel, obviously from Hager, from Electromechanica, we can offer you fans to cool down your system, which is by accident and also my category, category 8, as well as panel air cons that we do for high temperature panels. Then,
just before you move on to the next slide, we've just got a question from Ian. I'm just going to allow him to talk.
Ian?
Good day. I would like to know, would it be possible to get a copy of this video? I've got a friend that works at one of the colleges and instructs the students on electrical. And I just feel that this presentation as a video would be very useful for the students to actually sit and watch, and they would therefore be far better informed when they enter the industry.
Okay, Ian, I can answer that one for you. So yes, we will be sending you through a copy of the video. It'll be sent through an email within 48 hours after the closure of the webinar.
Okay, because in the past, when I've requested the video, I've never been sent a link to download it or the video for a couple of the presentations that I've seen.
Okay, that's okay. We're sorry about that. They normally are all sent through within 48 hours. But if you would like, they are loaded onto our YouTube channel as well. So if you search for Electromechanica on YouTube, they're all loaded on the YouTube channel.
Okay, cool. I'll do that. Thank you very much.
Ian, and thank you very much for the interest. It's much appreciated. Then, if you take this same 100 amp C-curve circuit breaker, and what we say is it's short circuit. Excuse me. It will trip within 0.01 seconds, and what it means is that we're getting to the IN rating of the circuit breaker. So we said a C-curve IN rating is between 5 to 10 times. So between 500 amps and 1,000 amps, this circuit breaker will come out on short circuit. So although the product might be rated at 10,000 amp on short circuit, this breaker will start opening between 500 to 1,000 amps. So again, if we go back to the scenario earlier about the motor starting or the motor running at 100 amps and that start up, even the C-curve product most probably will come out and see it as a short circuit and open and trip the circuit breaker, and the motor will obviously not run. So for motor applications, and depending on the startup currents, a D-curve is normally the preferred way to go for motor starting applications. Okay. Then we do get a lot of questions on DC applications. So the question is, can the Hager miniature circuit breakers be used in DC applications? And the answer is yes. In Annexure 9 in the Electromechanica catalog at the back, there's a DC table at the back that you can use for this application. So A customer wants to protect a 40 amp circuit breaker with a DC voltage of 500 amp and a short circuit current of 10 kA. So which MCB should he then use? So you can then go to the Annex 9, as I said, in the catalog, go to the table, and what you can do is, because I mentioned 500 volts, you can draw a line down from 500 volts down to see where the possible fault level can be at 10 kA. Obviously, if it's 6 kA, you can still use the 10 kA product. If it's then 250 volt, you go just a little bit to the left and you draw a line, and you can see that for 250 volt, you can use the same product, just at a different number of poles. So reaching your 10 kA, you can go to the left, and it will then mention to you that you must use a 4-pole product, and you can use any of the ranges on the left, NFN, NGN, NCN, again, depending on the tripping curve that you would like, BC or D curve. And then 4-pole is, sorry about the snapshot I took out the catalog, the Hager catalog. It's not the best picture, but you can see there, that's the way you will then wire up a NCN 4-pole product to be used as 40 amp at 500 volts DC. So these products are rated DC. You can just have a look at the table at the back to see which one you can use. Then just on the product offering, so on the miniature circuit breakers, you can add a lot of accessories onto the product to give you different scenarios. So if you want to do remote tripping, you want to put a shunt trip onto the product, UVT, and even an over and under voltage tripping device. You can add that to a miniature circuit breaker. I'll show you just now how to do that. You can also have a remote indication. So remote indication is just a normally open, close auxiliary contact to give you a signal whether the breaker is on or off, if you want to put it into your automation system, or indication light on the panel to see if the product has been tripped. And the way it works is, I do have, just quickly going to stop share here so I can show you the products. So if you look there, this is hopefully you can see it, this is the NFN product. Inside of the product, there's a small clip here for you to fit in the auxiliaries. So what you do is you just remove it. You've got a hole on your product then. You can then take the, as I said, the auxiliary. You can, let me try and do it this way around. You can then just clip it onto the product. Bottom, there's a clip that you just open and it clips in. So now you've got a miniature circuit breaker with a normally open close contact on that. But even now, if you would like to add a shunt trip to this, it's still possible. Again, I've already removed it. There's a small cover that closes the entrance there. So you can then take your shunt trip, exactly the same. You clip it onto the product, okay? At the bottom, the same mechanism, that you just open it and you lock it into position. And now you've got a miniature circuit breaker, auxiliary contact, normally open, normally closed, and a shunt trip if you want to remotely switch this product off, or safety emergency stop button to trip it. You can also add in a, I'm going to share my screen again. You can also add in a UVT, which is a under voltage strip, which is also a good thing to add it, because what happens is in the reticulation system that we use in South Africa, especially in the residential area, you've got a 3-phase cable running in front of your house, and it taps off line 1 to house 1, line 2 to house 2, line 3 to house 3, and then line 1 house 4 again, and it goes on like that. So with things in South Africa, they they like to steal the earth bars. And when you lose your earth, you're still lucky to have your neutral. But if for one of other reason the neutral get damaged, the house actually switches over to 380, 400 volts and starts damaging the equipment inside your house. So by adding a over voltage relay, you can actually protect your installation with a over voltage unit. The same for UVT. The UVT, where they use that mostly is in mining applications, because underground you have the possibility of methane gas, and they don't want the electrical equipment to switch automatically back on again. So you need to go down underground with a special tester, go and look for methane gas, and only when it's safe, they will switch back on this equipment. So that's where the UVT comes in handy, just for interest sake. Okay. Some advantages of the products and the commercial offer, just in short, we offer from a 1 volt four-pole product. B, C, and D curves. Smaller is 1 module wide, which is around about 80 millimeters. And then the 80, 100, and 125 amp products are a little bit wider, which is around about 27 millimeters wide. And as I explained to you with the miniature circuit breaker, the lockout mechanism on the product, some of the bigger products, the 80 to 125 amp, actually got this black, what do you call it, pull-out mechanism on the toggle. So if you actually pull this out, that is also a lockout mechanism, and you can put a small cable tie or something through it, just to ensure that nobody switches this product on or off, which is a nice feature. So you don't need to have a special clip going around to do the lockout of the product. Okay. So that is, in short, the miniature circuit breakers, the technologies around it, the thermal, the magnetic, what it means, the IN rating, and then the short circuit and tripping curves. Now we get to the RCDs, the residual current devices. Again, there's a lot of abbreviations, and one do get confused about what is a ELCB, what is a RCCB, what is a RCBO, when do I use earth leakage relays, and then, so why must we have earth leakage protection? I mean, if the installation is done properly according to regulations, they're not supposed to be any live wires. If your wiring accessories in your house, you plug the shutters inside is working, you're not supposed to be able to put something in there that can actually electrocute you. So why then use earth leakage protection? So a 1 minute quick survey just to see if you guys know where in the world was the first human protection earth leakage device designed and manufactured. Well, I've given a minute, so you've got another 40 seconds to please use the chat function and see if who knows whether the first earth leakages were manufactured.
Ian has answered first and is correct.
He's been around the industry a while, huh? Okay, so a few years back, I worked for another company, and the rumor had it that the first earth leakage device was manufactured in South Africa. And I actually went into it and had a look. And yeah, the first earth leakage in the world was manufactured in South Africa. At that stage, the company was called FJ Fuchs. And yeah, I then went and Googled it a little bit, and I found it in Wikipedia that Henry Rubin was the guy to actually manufacture the first earth leakage device or human protection device. And it all originated from apparently was a mine manager's wife in Storfontein that was electrocuted. And that's where this whole thing then started off. Nowadays, this is the standard. It's compulsory in most countries, even in South Africa, that all block circuits must be protected by earth leakage, 30 milliamps. And a big industry this. And just by the way, for history, Fuchs then eventually joined forces with Heinemann. Fuchs and Heinemann eventually became another company called CBI. I'm not sure if they still exist. Okay, so abbreviations for earth leakage units. So ELCB stands for Earth Leakage Circuit Breaker, and RCCB is a residual current circuit breaker. So what's the difference between the two of them? Both are circuit breakers. The one just says earth leakage, the other one says residual current. Matter of fact, they are actually both the same thing. And the confusing part of this is that it actually both refers to circuit breakers, which you would think will have overcurrent and short circuit protection, which is not true. Both these units are isolated type earth leakage devices. So it will only protect or give you protection against earth leakages or earth leakage currents in your system. So there's no overcurrent or short circuit protection on these devices. ELCB, RCCB is just the difference between older and newer terminology that's been used. RCCB is out of the IEC standards. Then you get a RCBO. So RCBO is a residual current breaker with overload. Unfortunately, I don't have a picture of a unit like this. It's not something that we as electromechanical really sells into this industry because we've got other solutions for this. And it also becomes a fairly expensive solution. The disadvantage of a RCBO, it looks like the normal RCCB or earth leakage circuit breaker like this, but it's got built-in short circuit and overcurrent protection. So the disadvantage of something like that is if something should go wrong, you lose your circuit breaker part of it, then you need to replace the whole unit. If something goes wrong on the earth leakage side, you need to replace the whole unit. So that's why I think the norm or the preferred way to do it in South Africa is to use a earth leakage device like this, and then just add a circuit breaker to that. Also, just for interest sake, is that a earth leakage device do not have a KA as per se a rating on it. It does have a withstand rating on it. So you need still to put a circuit breaker to protect it from short circuit. So RCBO is, as I said, is a residual current breaker with overload. It's something similar to the unit on the right. This is just the add-on device, which I will get to the next slide. Here we go. So an add-on device by itself cannot work. It cannot open or close a circuit. By itself, it cannot do nothing. But combined with the relevant circuit breaker, it then actually becomes an RCBO, which is a residual current circuit breaker with overload. The advantage of something like this is that in this application, the BDC240 is a 40 amp unit that can handle up to 40 amp. The MJT is a 2-pole circuit breaker in a 1-module application. And you can always take the circuit breaker off. This is a 16 amp product that's fitted to this 40 amp unit. But now if you realize at a later stage that you need to upgrade this product, again, it is easy. Actually, you just loosen your terminals, you slide it open, and you remove the product, you get a rating 20, 25 amp up to 40 amp. And again, you just add it onto the product, and there you've got a product RCBO with a higher rating on it. So definitely advantages using this above the normal RCBO. Then what other types of earth leakage do we get? You also get what they call an earth leakage relay. So this is this unit here. It's a DIN rail module that plugs into a DIN rail, and it's not being used in higher rated circuits. So for example, you've got a 400 amp circuit breaker and you want to add earth leakage protection to that. Although in the moderate case circuit breaker, you also have the option to add a add-on block, but you can also go for a earth leakage relay like that one. But with that, keeping in mind, you need to add a toroid, a CT, to pick up the imbalance. And then inside your circuit breaker, you need to add in a shunter, because again, this unit, there's no direct current going through, or current going straight through this unit. So the direct connect earth leakage like these ones, where the current actually goes through it and it breaks the current. This is done through the CT. It picks up the imbalance. This unit picks up the imbalance and then send a signal to your molded case circuit breaker, or miniature circuit breaker, or ICB even, to trip the upstream device. The other nice feature of a unit like this is you can do discrimination in your system on earth leakage protection. So for earth leakage protection discrimination, you can start off with a 500 milliamp setting at your main breaker, go down to a 300 milliamp breaker, and then even go down to your block circuits, which will give you 30 milliamp. Then also for discrimination purposes, you've got more flexibility, because you can do the settings on time as well as on the milliamp settings on the device. So you've got a lot more flexibility around this. And just for interest sake, as Electromechanical, we also offer similar products from Socomec as well as Lovato that does the similar thing. Okay, then why earth leakage protection? As I said earlier, if the installation was done according to all the required regulations, there's not supposed to be any leakage to earth. So the first reason would be because of alcohol and a little bit of stupidity. You can see these guys are also standing dead quiet, and you can see they're looking at what is going on here. So yeah, so alcohol you can call the one. This one is in a factory where it's an eye wash bin. So you actually need to drop your head down to wash your eyes through the water that will spray out there, and your head is touching the point there. Very clever, very clever. Good engineering. Then I can assume that this was a CA of a company, went on travel and realized when he gets there, he hasn't got a adapter for the country he's visiting, and he needs to do some reports on look at the financial statements, and he made a plan. Clever. And on this side, what can possibly go wrong? I mean, they did use wood, which is a non-conductive material. So yeah, well, there's nothing wrong with this. You can save a lot of money. You don't need to buy the SCARMI industrial wiring devices. You just would use some wood pieces there and you plug your cable in. No problem. But I think the most important part is we're not always around there to protect our family. So in this case, it's a kid playing with plugs and you're not there to protect him. And that's the main reason for earth leakage devices, is to keep the unknown protected from electrocution. We're quickly going to take a 5-minute break. I'm going to show you a small video, just like 1.5 minutes long, it's not very long. It's not necessarily to promote circuit breakers, it's just to show the capability of Hager, and that they also do have other products that can be used as well for automation purposes. See you in 4 minutes. Enjoy. So I'm out of breath, back where I'm supposed to be, with 250 people working for Electromechanica. I had some traffic jam running out of here. So that was the first part of the session. Hopefully you guys enjoyed it. As you can see at the back of me is a Quadro Plus panel and with a Vega D distribution board, just to show you some of the offers that we do have that we can offer you. And just for interest sake, we also do panel lights with occupancy sensors in them. I'll show you. So there's a panel light with a occupancy sensor in it, and it will only switch it on where there's movement. Not sure if you know that these occupancy sensors cannot work through glass. So I can move as much as I want here behind this panel now, and when it goes off, I will not be able to switch it back on again. So instead of putting a panel light with a switch, also put one with a occupancy sensor in it. Hopefully I get a bonus for adding more products to my presentation. Okay, so what is discrimination and what is cascading, and why is this important? So we'll take an example, Michelangelo Towers, penthouse 1, penthouse 2, cause your arm and a leg to stay there. And what happens if a overcurrent occurs in penthouse 2? What's going to happen? Is penthouse 2 going to trip, or is the upstream breaker from there going to trip? And this is where discrimination comes in. So according to discrimination, total discrimination according to the IEC standards, this is a type of current-based discrimination wherein there are 2 circuit breakers in series. The circuit breaker on the load side affects the protection without causing the upstream circuit breaker to trip. So what they mean is that if something goes wrong and it's proper discrimination, the downstream breaker will open and only penthouse 2 will lose power to it. And then your main supply to these 2 penthouses will stay on. So overcurrent occurs, the bimetal starts heating up, your breaker opens, and penthouse 1 carries on with normal life, and nothing interrupts their supply. So there are a few different ways of doing discrimination. So you can do discrimination by curve, B, C, and D curves, slow, fast tripping curves. You can do it by more molded, well, this application, I've used normal current discrimination, where you use different current ratings, upstream, then downstream. And then obviously in multi-case circuit breakers, you also have the functionality of setting the electronic side of it, the time delay. So you can play around with time delay on multi-case circuit breakers to get the effect of discrimination that you would like. Then what's going to happen without discrimination? So the previous application, you saw that there was a 125 amp breaker upstream and 63 amp at the 2 penthouses. This application, the person doing the installation did not look at what they were doing, and they installed a 63 amp circuit breaker as a main incomer, and then a 63 amp at the penthouse and at the penthouse. So penthouse 1 is pulling 40 amps, so what might be, and in penthouse 2 goes into a overcurrent scenario. Again, bimetal starts heating up, and then before the breaker can open, you lose your upstream circuit breaker, and both penthouses goes off. So just think if you stay in penthouse 1 at a cost of 10 grand a night, whatever the case may be, and you lose your power, you're not going to be very happy. And I mean, this is now in a residential application, so it's not that terrible. But when you go into more serious scenarios in hospitals, manufacturing facilities, for them to lose their whole income is a big problem, because as soon as you lose power, you lose income. So this was just on a scenario with discrimination in a residential application. Penthouse. Okay, so what is cascading? Okay, so cascading is the use of the current limiting capacity of a circuit breaker at a given point to permit installation of lower rated and therefore lower cost circuit breakers downstream. The upstream compact circuit breaker acts as a barrier against short circuit currents. So why would you use cascading in the first place if it is a problem? So by using cascading, what they say is that in this scenario here, you've got your Quadro Plus distribution board at the back. This board is rated at 40 Ka short circuit capability. So your main incomer must be 40 Ka. Now you go downstream from this, and you want to protect the light circuit, a 10 amp light circuit or a 20 amp plug circuit. To put in a 40 Ka molded case circuit breaker here to give you a fully rated board is fairly expensive. This board will also then go much bigger because it takes a lot of space up, and it becomes just a big, massive problem. So by using proper cascading, what we're saying is that in this board that's rated 40 Ka, you can actually put a 10 Ka miniature circuit breaker inside this board. And the way the cascading then works is that if a short circuit does appear in the feeder for chiller number 2, what will happen, instead of opening this product, the main incomer will open and protect your whole distribution board. Yeah, you might lose power to the whole board, but at least the cost in doing this is a lot lower than trying to do a fully rated distribution board. Keeping in mind that when you do a cascaded board, there must be a label on the board saying that it's a cascaded system. And when it is a cascaded system, you're not allowed to change a product inside that board with something else than the product that you take out. So you cannot take a Hager product out and replace it with a Chin, Swan, whatever, any other manufacturer. That is actually illegal, because as soon as you do that, you lose your cascading capability. And what happens, I'll show you in the next slide what can happen if something like this do happen. So let's say a short circuit occurs there. What will happen? There's no time for a bimetal to heat up or nothing. It just happens immediately. Both these breakers will open, and the majority of the short circuit will be in the molded case circuit breaker that can actually handle 40,000 amps, keeping this breaker safe and protected. So this is the reason you will use cascading. In scenario 2, somebody worked there and by accident did not look at the breaker they're replacing, and they took a 10 Ka product out and they replaced it with a 3 Ka product, maybe from the same manufacturer. The problem with this is that this installation or this method of cascading was not tested. So what could happen is when a short circuit appears, again in this circuit here, the circuit will open, and this 3 Ka product will not be able to handle the 40,000 amp that board is rated. And what will happen is that you may have a huge explosion in your installation. and cause a lot of damage. So instead of just losing the power supply to the installation, you might lose your whole board. You've got a shutdown period. You need to replace the products, you need to replace the board. And instead of, sorry, excuse me, a quick reset of one product, you're now sitting without a board, maybe for a day or two, whatever the case may be, to fix this. And the cost involved is huge, and replacing all of this, and the manufacturing part of it is you lose manufacturing capability. So that is the difference between discrimination and a cascaded system. So how do we read a cascading table? Again, Annexure 10 in the back of the electromechanical catalog is the table for cascading. So you've got a 35 kA rated distribution board with the 250 amp multi-case circuit breaker as income, and you want to install miniature circuit breakers to protect the 63 amp feeders going out of the board, maybe to a sub-distribution board, or even you can install it 40-20 amp miniature circuit breaker to protect plugs and light circuits. So you look for a 250 amp main incomer that's rated 35 kA. So for 35 kA short circuit, you are allowed to go higher. So if you don't find a 35 kA circuit breaker, you can go to 40 amp. It will still open at a certain time. The only difference is that the 40 kA circuit breaker can handle 40,000 amp short circuit. So no problem in going bigger. So we now found that the X250 range with the TM, thermal magnetic tripping technology in it, will be suitable for my application. So now I've got the circuit breaker that I want to use. I then draw a line downwards to see which other product can handle 40,000 amps when used in a cascaded system. So then go to the left and you will see, oh, okay, so I can use an NFN 10 kA product. Awesome. Now this is a cascaded system. If you use an NFN 10 kA product underneath an HNB 250 in a 40 kA application, you will be safe in doing so, because these scenarios has been tested like this. And this is guaranteed by the manufacturer that you can use it in this specific application. Just by the way, this is actually, I've dealt with a few cascading tables in my life, and this application for cascading is actually very, very good. It might be better than most of our competitors out there. So it's really cascading, Hager cascading is really a good solution to be used. Then why to use the Hager products? Again, I discussed a lot of these features already. It's the markings on the product, the markings on the side, QR codes on the product. You can see the status of the products on off. You can fit accessories to that. There's a warranty from the supplier, and obviously we will honor the warranty from Electromechanica's point of view. It's a product made in France, so it's it's good quality products. A lot of the markings will be on the front that you can see. So it's from Hager, from a circuit breaker standard. This is really a good products that can be used in the application. A lot of smaller features that's in the process not always visible, or that you're not always told about, is like on the MJT product, which is a new one that we've added into the catalog. You will see later on I've got an explanation of the MJN to MJT, but in essence what it is this is the MJT, and you've got two clips at the back of it. So what will happen is you'll clip your product into a DIN rail. You'll have your wires on the top and at the bottom, maybe a bus bar on top. And then you would like to replace a 60 amp with a 20 amp, or you decided to go small and want to include a 10 amp. So instead of loosening all your bus bars on top to take this product out, because normally that's what you need to do, is you need to remove everything on top, so you can clip this product out of the installation and take it out. But what they've done is, with the 2 clips in this instance, you can actually unclip it on the top and at the bottom, okay? And you clip it out and you can slide it out of your product without needing to loosen all your bus bars and cables on top of the product. So behind the scenes, there's a lot of other features that's, as I said, not always mentioned. Just a quick reference to what was in the 2017 catalog versus the new 2020 catalog. We have the MV range is the same, although there was a little bit mistake in the catalog. We mentioned it as a B curve. It's not a B curve. The MJN was replaced by the MJT. The MN was replaced with the MA range. And you can see that there's a few product changes, but in essence, the product changes was more to benefit the customer than anything else. The difference between MJN and MJT was that the MJN could not take accessories. It could not have an add-on earth leakage device, where that was possible with the MJT. The MN that we replaced with the MA, again, it's more benefits to it. The MN also could not accept accessories to that, where the new MA can. And there's just a summary of changes within the catalog. For the ease of use and to try and assist our customers when selecting miniature circuit breakers, we actually added in this table here. So to try and make it easier for you to select a product. So if you want to look for a 10Ka product, you can see 10Ka. Which do you want? Do you want a D curve? Do you want a C curve? No, I want a C curve. Okay, then you can look between these two. What current rating you're looking for? Up to 63 amp, you go for this range. And for 80 to 125 amp, you go for the HLF range. And then it will also guide you to the catalog page. So you'll find this in page B3. I have just some technical information. Can it accept add-on earth leakage device? And can it be used in DC applications? Then you can always go back to the table at the back. And then this is the width of a module. So it's 17.5 millimeters wide from one side to the other side. The bigger ones, the 125 amps, they are 1.5 millimeter wide. So it takes up a little bit more space, but you can go up to 125 amp in a miniature circuit breaker. So in the electromechanical catalog, a lot of information you will find there. If you don't find the information or you're not sure about something, you're always welcome to contact myself or the technical support team. That, by the way, is also now available on Saturdays, if you didn't know that. So if you work on a Saturday and you need some technical assistance, we do have some people available on Saturdays to assist you. So in the catalog, there's the frequency the product can work at, the voltage the product can work at, the fault level, the current rating, the poles, and also the list price of the products. Keep in mind that this list price, there was an adjustment earlier the year during COVID. So this price is not accurate anymore. But that's one other feature that does give Electromechanical an advantage above a lot of our competitors, that we still do printed catalogs with pricing. Just more about the information in the catalog. The tripping curves are all available. It's there. It mentions the standards that we comply to. Okay. I think this is about the end. I don't really want to go into details on all these products. There's a lot of slides going down, explaining the MV product, that's 3 Ka, the features of it, the MJT that can take a add-on earth leakage device. It's a 1 pole plus neutral product, so meaning the neutral is not protected, it's just an isolator. The 2-pole products in the other ranges are both protected, so it's overcurrent short circuit protection on both these poles. The MA range, we've got the NF, so just be careful when you order here that up to 40 amp it's called the NF range, and for 50 and 63 amp it's called the NFN range. You know, we can, there's a lot of time we can spend on all of these slides. We can go through them one by one. If you need more information, you're more than welcome, as I said, to contact me. Nothing major about these products. So the NRN product, you'll see that it's got different fault levels depending on the current rating of it. So for the NRN up to 63 amp, can be used in a 15 K application, and 6 to 25 amp, you can use it up to 25 kiloamps. Then if you go to the bigger products from 180 to 125 amps, the offer in there, which is you get a C curve, you'll find a D curve, and 15 Ka again. And mentioned again, you can see that there's the lockout possibility if you would like to use it on the breaker. 30 Ka miniature circuit breaker. You will also find all the accessories that I showed you that can fit on the products. Auxiliaries, the alarm contacts, the shunt trips, the under voltage, over voltage relays, all the accessories. If you would like to use the lockout mechanism, there's the mechanism that you can put onto the breaker, the different bus bar solutions, then isolators for applications, up to 125 amp again, 1 to 3 poles if you want 4-pole products, also available to the SANS 609 or IEC 60947-3 standards. Then another very popular product is the DIN rail mountable changeover switch, becoming very popular. Thank you Eskom for load shedding. So we sell a lot of these products, very popular, because a lot of the competitors out there, I'm talking about the big brand competitors, they can only go like 20-25 amp in something like this, where we can offer up to 63 amp, which is very suitable for residential and small commercial applications. Then the different add-on blocks, earth leakage devices that you can get for the different miniature circuit breakers, different milliamp settings, 30, 300 milliamps, 2 4-pole devices, 3-pole devices, all depending on where you want to use it. The normal residual current devices, the units without earth leakage, without the overcurrent short circuit protection, which is an isolator type earth leakage device. The earth leakage relays that I mentioned, the different units from Hager that's available. Keep in mind that there's also the others from Lovato and Socomec. Karen, I think this is more or less the end of the presentation. I would like to once again thank you for participating in this and giving us the opportunity to showcase the offers that we have on hand. You're always welcome to contact me, as mentioned. I'm always available. There's other products that we also do. Then these are the upcoming webinars that you are more than welcome to attend, or I urge you to please attend them. It takes a lot of time to do the preparations for these things, and we would like to showcase what we as electromechanical can do for you. Karen, anything from your side?
No, well, thank you very much for the informative webinar today, Christo. We trust you all enjoyed it. As Christo mentioned, we do have a list of upcoming webinars. You can register for these on our website, www.em.co.za. Also, all of the prior webinar recordings are available on the YouTube channel. So if you'd like to go back and have a look at any of the prior webinars, please go and have a look on the YouTube channel. And I'm going to launch the poll now. If you wouldn't mind just taking a few minutes of your time just to answer a few questions for us. But apart from that, thank you very much and have a good day.
Thank you, Karen.